I have the strange experience of being the chair of the session in which I'm also speaking, so I'll have to keep myself on time when it comes to that. No, I'm very pleased to be here. I'm the director of the CDS. I'm chairing this session. I was hoping that the organisers might walk in before the beginning of the session. They're coming? I've been asked to wait for 2 seconds.
You already have your presentation on the computer? Yes. Okay.
Well, let me go ahead and introduce Pepe after all. Pepe Fabbiano is a senior astrophysicist at the High Energy Astrophysics Division of the Smithsonian Astrophysical Observatory and also associate of Harvard University. Pepe, of course, has lots of experience managing the processing of data for the Chandra X-ray Observatory. She also is the chair of the IVOA, the International Virtual Observatory Alliance, and leads the VO activities at CFA and in the US VAO project. So Pepe is going to talk to us today about the IVOA with the title IVOA, the Standards Organization for Data Interoperability in Astronomy.
Actually, I should say I'm not just in charge of the data processing of the Chandra data. In my purview, it's all the software development, hardware, and archive as well. So it's
Okay,
all
thank
data
you.
systems. Okay. Assume it's this one. No. Dov'è? This is different from... giusto. Yes. Okay.
This is the presenter for...
Great. Thank you. Yep. So what I want to talk about here, is this good enough? I think it will be. Yeah. No, this is fine. I'm just. I'm going to give a general overview of the International Virtual Observatory Alliance, which is the standards organization for data interoperability in astronomy. And we already heard about the IVOA before lunch break. I'm going to take a step backwards and try to define the virtual observatory because I think that will give us an idea of what we want to do. So one definition of the virtual observatory is that it's a multi-wavelength digital sky that can be searched, visualized, and analyzed in new and innovative ways. And this includes space data, but it also includes in the same way ground data. And we shouldn't forget about theory data, simulation data. A different definition is that the virtual observatory is the latest stage of good data practices in astronomy. And if you take a bit of a historical view, we started with each data center or archive with a different or slightly different file structure, metadata, and table organization. So we have the data, but it takes work to access it. So the data is public, it's open, but it's not transparent, and it's particularly difficult to access it, especially several data sets are used together. Then FITS came, and FITS provided a first standardization, not complete, but a good path forward. What the virtual observatory wants to do is enact the natural progression towards interoperability of data, not just data, but also services and tools. Another definition, which I kind of like, is that the virtual observatory will provide new science, and will provide new science via a three-pronged approach. We start with good data management and access, as I said before, and as everybody here has showed, or several people, if you have a good archive, most of the publication come, and this is the Chandra version of a plot you've seen before, come from archival data, not from the original observer. So the archive, a well-managed archive will foster data reuse, new science, and public awareness. Then there is the interoperability. So what we want there is a flexible analysis environment that will put data, tools, and literature seamlessly together at the astronomer's fingertip, and I will show some example. And finally, big data. This has also been touched upon before. We need workspaces, collaboration tools, data mining tools, and services. All of these will take us to the next generation of data science and astronomy science. So the virtual observatory is, you can also say, it's a paradigm for supporting interdisciplinary and collaborative research, education, outreach, and we can put in there also citizen science in astronomy, exploiting the full power of growing and emerging data sets. I want to stress that the virtual observatory is not a fixed system, but it's a way of doing things. It's a framework, and it's a framework for data centers to collaborate and provide cooperating data services, and also for software providers to offer a variety of compatible analysis and visualization tools and user interfaces. How do we achieve that? We achieve it because we have a set of protocols, or standards, which is at the core of the Virtual Observatory. And these are standards developed within the International Virtual Observatory Alliance, IVOA. And these standards include standards for data and metadata for all kinds of observed and simulated data, data exchange methods, registries or lists and characteristics of the available services, and finally, application messaging protocol. So VO enables tools and services can interface seamlessly with VO-enabled archives worldwide. New data systems with the Virtual Observatory at their core, and the IVOA standards and protocols are being developed worldwide, as, for example, Christophe was telling us about in the ESA environment, and also in the Canadian CADC, so Gaia, Euclid. Australians are also taking this approach, and a growing number of data centers. A bit of history. The IVOA was created in 2002, and now has today has 23 member projects, and there are 2 well-attended interoperability working meetings that we do per year, where people really develop their standards. Another thing I want to stress is that the IVOA doesn't have any direct funding. And so the affiliated projects, they have to seek funding from their national agencies. And that means that with the fluctuation of funding, some members have come and some members have gone, some projects have persisted and others have stopped. But overall, things are working. And we have learned how to do this work. We have learned how to manage the development of standards via a very solid management framework and the user roadmaps for development. And we have absolutely demonstrated that the participation of users in this process is important, because you cannot have a standard imposed from the top if the standard doesn't do it for you. And altogether, we are still there, and we're, I think, doing well and being more recognized, and this is because the Virtual Observatory it's a good idea. Here is an organization chart. There is a top and a bottom, as many of these charts. The work all happens in the bottom, most of it. So there are 6 working groups, each one per standards area, and 6 interest group per areas, which are kind of relevant for either present or future development of standards. And also a new one we have is operations, that validates all the service worldwide that run IVOA standards and based on IVOA standards, make sure everything is up and working. The management of this layer of working groups and interest groups, and these are the groups that meet twice a year. They also work not face to face, but via internet. But the decision is usually made in this work in these 2 yearly meetings. There is a technical coordination group that consists of the chairs of each of these groups. And there is also up there a Standards and Processes Committee, which is the committee that has developed the rules for this collaboration, and that's been absolutely important. There on top, there is the Executive Committee. Those are representative of the 23 participating processes, and the Technical Coordination Group reports to the Executive Committee. The Executive Committee has a prong out to the science world via the Committee on Science Priority, by which scientists and new emerging projects are invited to come and tell us what they need and invite to collaborate. Let me give you some IVOA successes. We have a stable architecture. I'm not going to go into details, but a number of protocols developed, all those blue boxes. And we have stable processes, absolutely fundamental, a way how to achieve those protocols. The documents are all accessible via the www.ivoa.net and also published in the NASA ADS, so you can search by author name. There are several big archives in the Virtual Observatory. We heard about the CADC and ESA, but we also have CDS. We're going to hear that next. The Space Telescope Archive, MAST. URSA is the infrared archive in NASA, the Chandra archive, and there are several interfaces. And this is, for example, is the MAST interface, which I don't know if you can read those little boxes, but they will give you access not just to the Hubble data, but also to other data, for example, X-ray data. You can go to Chandra from that, or you can you can go to ESA from that. So it's all interconnected. Virtual Observatory in data centers is another success, and I think we heard very much from David Shades about this, and the fact that the CADC, but also the new ESA archives, are built around these protocols. So they're native in there. You don't have to change your architecture to put a layer of interface, which lots of us have had to do, but now you can build your archive based on the IVOA protocols. Reliable operations, that's a very important point, because we have hundreds of VO services in the IVOA registries. Are these services all compliant? Because if they're not, a user may go there and the thing won't work. That's bad. So we have validators, and there is a new, relatively new IVOA operation interest group that monitors operations by running validator. The chair is NASA, Tom McGlean of ISARC. An aspect of the IVOA that I particularly like, being a working scientist, is the seamless science. It's a new paradigm for research integrated archive, literature, and analysis session. So you have IVOA compliant user interface, and you have IVOA compliant query protocols built on the interfaces built on these protocols. We have SAMP, which is a VO interoperable application protocol, and we have archive that link with literature. For example, in the case of Chandra, but there are other archives have these two-way links by which you can search a paper and you can find data that go with the paper. This has to increase in use, but in the basic, it's there. Now, what can you do with such a system that links your data with your tools, that allows you to do database queries and then do analysis and search the papers that are written on this data? You can do a lot, and people are doing a lot. Here, I'm giving you a few examples of tools that people use, and the average astronomer will not know that these are VO interoperable applications. They'll use them. And for example, DS9, even TopCat is used a lot by lots of people nowadays, and there are some spectral engines. Iris is a photometry engine, and of course we'll hear about the Strasbourg application. All of this is there, and all of these tools are VO enabled, so they can work together. They can work with the archives, the major archives that are VO enabled. And later, if anyone is interested, I have a demo on my laptop. I'm not going to show here, but basically you can do analysis session by searching in a VO, general VO archive in the top there, the VO data with TopCat, deriving a list of sources that then you can search against another archive, for example, the Chandra X-ray archive, and iteratively and interactively do plotting, finding outliers, go to the data products and do spectral analysis, do scripts. Python scripting is in the VO C, and all of this can be done in one analysis session. It's very powerful, and it really produces new science in an easy way. So this is the thing I'm not going to use. Finally, education, outreach, and third-party application have also been enabled by the IVOA standards. I have two examples. EuroVO for education, which is a suite of IVOA compliant tool and use cases, and the top box there has some use cases, and you can see all the flags of various groups and nations that were part of that use case, and even commercial software like Worldwide Telescope. I mean, it's open source now, but was developed by Microsoft, was inspired by the Virtual Observatory and is compliant with the Virtual Observatory, and is now the American Astronomical Society has adopted it as a main outreach engine. Now let's go to the new project engagement in the IVOA. As I said before, the development of standards is not, should not be a top-down activity. It's very important that we listen to the users. The input of the project is important, but not just the input, also participations, because a project needs to try out these standards, see how they work for them or not, and come back to us and be part of the development. So new science projects are welcome to participate in the standards definition and development, and that happens in this IVOA process. This is an example of how this may happen. There is the IVOA Committee on Science Priorities that seeks input for science driver, and Mark here has been the chair for a long time. And for example, this process has identified fast track standards. One of the ALMA needed a data cube, so we started working on data cube standard. This committee also organizes focus sessions with project in Cape Town. In May 2016, we had a session that was titled Interoperability of Data from Major Astronomical Observatory. And if you look there, presenters and science project telescopes, you see a representation from all the major upcoming big telescopes. So, just to conclude, I want to say that the VO is not a killer application. It's not a one portal that everybody jumps in and then you find yourself in this wonderful universe. Instead, it's an evolving ecosystem, and the IVOA defines the virtual observatory ecosystem and the standards. The registry, the virtual observatory registry, archive interfaces, and VO-enabled software give entry points to the resources of the virtual observatory, visualization, and analysis. But it is to the astronomy projects and data services to build VO services and applications based on these standards, and so serve the community. And new projects are welcome and encouraged to participate in the project of standards and within our frame. So I would like to say, if this Open Universe project goes ahead, which I think is a very good idea, I would welcome you to somehow find a way to be part of the IVOI family so that we can develop, as needed, standards that will serve your need and will serve our need as well, and grow on whatever we've been doing for the last 15 years. And that's it. Thank you.